Now we're going to move the trapezoid onto the coordinate grid. So we're going to take our quadrilateral QRST with our vertices of -8, -4, 0, 8, 6, 8, and -6, -10. And we are going to graph that right here. Now we're going to move through these different slides and we're going to show that this is in fact a trapezoid and determine if it is an isosceles trapezoid. So first step, graph it all on there, boom, done. Next, we're going to use the slope formula to compare the slopes of the opposite sides. QR is going to get compared to ST, and QT is going to get compared to RS. A quadrilateral is a trapezoid if exactly one pair of opposite sides is parallel. When we compare QR and ST, we find that their slopes are both 3/2. Because the slopes are equal, we know that they are parallel to each other. When we compare the slopes of QT and RS, we find that one is -3, QT, and one is 0, RS. Because the slopes are not equal, we know that they are not parallel to each other. Because quadrilateral QRST has only one pair of opposite sides that are parallel, we know that quadrilateral QRST is a trapezoid. So that's our first part. We've determined that it is in fact a trapezoid. Now we want to know, is it an isosceles trapezoid? So in order to figure out if it's an isosceles trapezoid, we have to compare the distances between QT and RS, because those are the legs of our trapezoid. The trapezoid is isosceles if these two lengths are congruent, if the legs are the same length. So we take the distance from Q to T, and we find that it is the square root of 40. And we take the distance from R to S, and we find that it is 6, right? 2, 4, 6, right there, 6. Because they are not congruent, because the square root of 40 is not equal to 6, the legs are not congruent. Therefore, trapezoid QRST is not isosceles. It is a trapezoid, but it's not an isosceles. What other method could you have used to show that the trapezoid is not an isosceles? Think about that, put your answer in your notes, and have it ready to go for later.